In this session we're going to discuss products and quotients involving radicals, and we're going to start with products or multiplication. Alright, so multiplication of radicals, and in many ways this is very similar to what you're accustomed to doing when you're multiplying polynomials. Alright, so let's look at a problem like this. Alright, so we have the square root of 3 out right next to the parentheses, and inside of the parentheses we have square root of 6 plus square root of 12. Now we've discussed in a different session how because the square root of 6 and the square root of 12 are different numbers, even though they're both under a square root sign, they cannot be combined. Okay, so seeing as they can't be combined, they can't do the addition that's inside of the parentheses, the next available operation that's to be done would be distribution, because you have this radical next to the parentheses, so you distribute. Alright, and when it comes to multiplication, you can multiply the terms under the radical as long as they are under the same type of radical. So in other words, since this 3 is under a square root and this 6 is under a square root, they can be multiplied. This 12 is under the square root, so the 6 and the 3 and the 12 can be multiplied. Okay, so same radical allows for multiplication. However, let's just say for a quick second this was cube root of 3. Alright, and I was trying to multiply it by the square root of 7. Okay, you cannot do that because this is cube root, this would be square root. They're not the same type of radical, so you could not multiply them. You'd have to have a situation where if you were doing the cube root of 3, it'd have to be the cube root of 7. Alright, now you could multiply because they're under the same radical. Alright, so that's why we're able to do the multiplication over here, this distribution, because they're all under the square root sign. Okay, so just wanted to show you that right quick. Now going forward with actual multiplication, the 3 times the 6 would give you a 18, the 3 times the 12 would give you, what is that, 36. Alright, 18 we always look to simplify or put in simplest radical form, and that's like saying the square root of 9 times the square root of 2. Alright, square root of 9 can be broken down to 3. Square root of 9 is 3. Square root of 2 can't be broken down. And we have square root of 36. 36 is a perfect square, so square root of 36 is 6. Alright, so that would be our answer. Okay, would be 3 square root of 2 plus 6. Okay, let's say if we had a cube root. Okay, if we had one like cube root of 2 times 5 cube root 4 minus 3 cube root 16. Okay, they're all to the cube root, so you can multiply as long as the root is the same. Alright, can't combine in here, can't subtract these in here, because even though they're to the same root, the number under the radical, inside of the radical, those are different numbers, so you can't do the subtraction in here. Okay, alright, now so we're going to multiply a cube root of 2 times that, cube root of 2 times that. Alright, since this is under the radical, it gets multiplied by what's under the radical here, which in this case, is a 4. Okay, so what I'd be looking at would be 5 cube root of 8, because 2 times 4 is 8, minus 3 cube root of 32. Alright, because 2 times 16 is 32. Alright, now 8 is 4 and 2. Let's see, 32 is 16 and 2. So what I get is 5, and the square root of 4 is 2. Alright, this 5, square root of 4 is 2, and I'm left with the square root of 2. Alright, because I can't break it down. Minus 3, square root of 16 is 4. Alright, and square root of 2 can't be broken down, so you just write it. So this is 5 times 2 is 10, square root of 2, minus 3 times 4, which is 12, square root of 2. And now look, square root of 2, square root of 2, same radical and the same number inside of the radical. So now we can subtract 10 minus 12, and 10 minus 12 gives us a negative 2. Oops, didn't mean to write it like that, excuse me. So it gives us a negative 2 square root of 2 for an answer. Negative 2 square root of 2 for an answer. Alright. Let's see here. Did I write that right? 16 times 2. 16 is 4. 3 and 4. Sorry guys. I know something was looking funny. I did this based on square root. This is cube root. Back to the drawing board. I knew something was looking crazy. Okay. Sorry about that. Alright, gotta keep up with this. This is cube root. Alright, so 8 is a perfect cube, right? So this is like saying 5 times the cube root of 8 is 2. So 5 times 2 minus 3 times, and 32 is like saying the cube root of 8 times the cube root of 4. Okay, so with 8 being a perfect cube, we just said 8 breaks down to a 2. Cube root of 8 is 2. We just showed it here. So here it is again here, and you're left with the cube root of 4, because 8 times 4 is 32. So the cube root of 8 breaks down to this 2. Cube root of 4 doesn't break down, it stays cube root of 4. So now you end up with 5 times 2 is 10, 3 times 2 is 6, and that's cube root of 4. So in the end, this is your answer. Sorry about any confusion. Alright, got caught up not paying attention to the roots, to the radicals. So make sure you don't make the same mistake. Okay, make sure you keep track of whether you're doing cube roots, square roots, or what have you. Alright, let's look at some others. Let's see, let's look at square root of 3 plus square root of 5 times square root of 2 plus square root of 6. Alright, now I mentioned at the beginning that treat the multiplication of radicals similar to how we would for polynomials. So really what we're looking at is what you would think of as a binomial times a binomial. Alright, so FOIL. So you could say first times first, so square root of 3 times square root of 2 is square root of 6. Outside times outside, 3 times the 6 would be square root of 18. Inside, inside, 5 times the 2 would be square root of 10. And then last times the last, which would be square root of 30. Now we simplify these. 6 we can't do anything with. It doesn't have any factors that are perfect squares, so we just leave that alone. 18 is 9 times 2. 10 can't be broken down any further. 30 is 10 and 3. 30 is 15 and 2. Alright, so I can't think of any perfect squares That'll give me 30, so it can't be broken down. So we keep our square root of 6. Alright, plus, now square root of 9 is 3, and we keep the square root of 2. Alright, can't do anything with the square root of 10, so we bring it down. Can't do anything with the square root of 30, so we bring it down. Okay, so when we multiply it all out using FOIL, here's our answer. Alright, square root of 6 plus 3 square root of 2 plus square root of 10 plus square root of 30. Okay, let's look at another one. Let's say we have 2 square root of 2 minus square root of 7 in parentheses, and then 3 square root 2 plus 5 square root of 7 in parentheses. Again, you could FOIL, so first times first. This 2 times this 3 would give me a 6. Square root of 2 square root of 2 would give me the square root of 4 for my first. Outside would be this times this, so the 2 and the 5 would give me a 10. This 2, this 5 gives me 10. This 2 and the 7 would give me square root of 14. Inside would be this times this, so you have your negative 3 outside, and you have your 14 inside, and then last and last here times last here, you have minus 5 square root 49. Alright, 4 is a perfect square, which gives me 2, so that'd be like saying 6 times 2. Alright, 10. 14 breaks down to a 2 and 7, which is not going to break down to any perfect square factors, so you leave it as it is. Minus 3 square root of 14, we just talked about 14 can't be broken down. Minus 5 times square root of 49 is 7. Alright, so minus 5 times 7. So this gives me 12. These two right here can be combined because they're both square root of 14s. So I can say 10 minus 3 will give me a positive 7 square root of 14. And then now here I have this 5 times this 7, which is 35, and you have your minus sign, right? So that's why this minus sign is here. 12 and 35 are like terms, so 12 minus 35, okay, it would be what? 23, negative 23. So negative 23 plus 7 square root of 14. Alright, negative 23 plus 7 square root of 14. Okay, let's look at another one. Alright, we have square root of 8 plus square root of 6 times square root of 8 minus square root of 6. Again, binomial times a binomial. But what I want you to notice about this one is these two binomials are really the exact same with the exception of the sign in the middle. Alright? They're both binomials. The terms are the same for the exception of the sign in the middle is the opposite. When you have a situation like this, it is referred to as a conjugate. Alright? And conjugates allow us to rationalize a denominator when we're dealing with fractions. It allows us to get rid of radicals in the denominator when we have a fraction, but we'll deal with that in a few. Right now, just wanting you to understand that this is an example of the conjugate. They're both binomials, the exact same. The only difference is the sign in the middle. That's what makes it a conjugate. And now that we know what it is, it's good to understand the behavior when you're talking about a conjugate. When you're multiplying conjugates, again, we said for a binomial times a binomial, we can do FOIL, right? And we've done it. Binomial times binomial, we've done FOIL. But when you have binomial times binomial and they are conjugates of one another, like these two are, then instead of FOIL, first, outside, inside, last, really all you need to worry about is the first and the last. You don't have to worry about the outside and inside. You don't have to worry about the outside and inside because they cancel each other. that's what makes them conjugates, because they cancel each other. Okay, so in this case, if I'm just doing the first and the last, first gives me square root of 64, last gives me negative square root of 36. Square root of 64 is 8, minus square root of 36 is 6, 8 minus 6 is 2. Real simple. Alright, let's look at another one. Let's say we had the square root of x plus square root of y times square root of x now minus square root of y. So binomials, the exact same with the exception of the sign in the middle. So the only thing different is the sign in the middle. So here, these are conjugates, and we multiply them. All we have to worry about is the first and the last. For the first, we get the square root of x squared, and then for the last, we have minus the square root of y squared. And we talked about in previous sessions how the square root sign cancels the square. Square root sign cancels the square. So you're left with this x, your minus sign in the middle, and this y. Alright, so your answer would be x minus y. Okay, and that's conjugates. Alright, now we talked about conjugates. Alright, and we showed that you don't have to do the FOIL, but you can just multiply the F's and the L's, the first and the last, because the outside and inside terms cancel. Well, the reason we introduce conjugates is so we can deal with division. So we can deal with getting rid of radicals in the denominator. Alright, so if we have a problem, let's say like this. Alright, we have radicals in the denominator, and this is a binomial. It's not a monomial, it's a binomial. When you have a binomial and it's radical based, then all you do is multiply by its conjugate. So the conjugate of this would be the exact same thing with the exception of the sign in the middle. I would change it to minus. Alright, and whatever I do in the bottom, I do also in the top, in the numerator. Okay, so now I can distribute my 4 and do F and L on my denominator. So in the numerator, I get 4 times square root of 5 minus 4 times square root of 2. In the denominator, I get the first times first, which is the square root of 25, and I get minus the last times the last, which is the square root of 4. Okay, square root of 25 is 5, square root of 4 is 2. So now what I'm looking at is 4 square root of 5 minus 4 square root of 2 over 5 minus 2, which equals 4 square root of 5 minus 4 square root of 2 over 3. Alright, so 4 square root of 5 minus 4 square root of 2 over 3, and this represents your final answer. Okay, let's look at another one. Let's say we have let's see what would be a good one. Let's go with square root of x plus 2 over square root of x minus 3. Okay, now because our denominator is a binomial, you can't just try to factor and cancel stuff with the numerator when it's a binomial. Okay, these are together, so the way we get rid of this radical here is we have to multiply by its conjugate. Okay, and its conjugate in this case would be square root of x plus 3. Whatever I do on the bottom, I do on the top. Alright, so down bottom I get square root of x squared minus 9, and up top I get first times first, which would be square root of x squared. Outside would be a positive 3 square root of x, inside would be a positive 2 square root of x, and last times last, which would be 6. Okay, so simplify. I told you the radical square root cancels square, just leaves an x. These are like terms, so 2 square root of x and 3 square root of x get combined to give me a positive 5 square root of x. Alright, and you're left with a 6. And then down bottom, square root cancels square and leaves you an x minus 9. Okay, x minus 9. Alright, so you have x plus 5 square root of x plus 6 all over x minus 9. There's your answer. Alright, let's look at one more. Let's say we have 2 square root of x minus 3 square root of y over square root of x plus square root of y. Alright, binomial denominator, so we use the conjugate. So square root of x minus square root of y, square root of x minus square root of y. Down bottom, I get square root of x squared minus square root of y squared. That's my denominator. And up top, first times first, I get 2 square root of x squared. Outside, I get a negative, what is that, 2 square root of xy. Inside, I get a negative 3 square root of xy. And then last times last, I get a 3 square root y squared. Okay, so 2 and square root and square cancel, leaves me 2x. Alright, these are like terms, they're both to the square root of xy. So a negative 2 minus 3 is saying a negative 5 square root of xy. Then square root and square cancel, which leaves plus 3y. All over square and square root cancel, square root cancel, x minus y. Alright, so 2x minus 5 square root of xy plus 3y all over x minus y. Alright, and that wraps up division, which really what we would call this technically is referred to as rationalizing binomial denominators. Alright, that's what we've done. We've rationalized binomial 1, 2, binomial 1, 2, binomial 1, 2. Alright, all of them started off as a fraction with 2 terms in the denominator, so binomial denominators. Alright, so that concludes this session. Feel free to contact me if you have any questions. At this time, we will now conclude this session.